Hi viewers, this is Sri Ramulu. So today's topic is a transverse wave velocity in a stretched string. So this is a part of wave unit. So it is from the second semester. Okay friends, let me enter into the topic. So today's topic is transverse wave velocity in a stretched string. So before entering into the this topic, first what is the meaning of transverse wave? Okay, so wave, we know wave is a disturbance produced by the body or in the body. Next, transverse means here if any suppose energy is traveling in one direction, if any particle in the medium vibrates perpendicular to the direction of the energy, then such a waves are called transverse waves. If the vibrations are along the direction of the length or along the direction of the propagation, such a waves are called, such a disturbance is called longitudinal wave. But here we are studying about the transverse wave. Transverse wave means vibrations must be perpendicular to the propagation direction. Okay, now consider it is consider a string of uniform cross section alpha. See, its cross sectional area is alpha. I am taking length L, linear density is mu, tension T is fixed between the two rigid support. Here what is the meaning of linear density? Linear density is mass by length, that is called linear density, and it is denoted by a letter mu. Okay, mass per unit length is called linear density. Let the string is stretched in positive x direction as shown in figure. Positive x direction means suppose if it is origin, so here stretching is along in this direction only. Let y of x comma t is the displacement perpendicular to the x direction. Y is x comma t. Y of x comma t means y is a function of x and time, distance and time. So that is why it is called simply y of x comma t, and it must be perpendicular to the x direction. Why? Because suppose the string is stretched like this, and if you pluck in the middle, then vibrations are like this only, up and down, right? Up and down means along y direction. Let us consider a small element dx in the string. So let me take this is a small element of a string, or small length of a string. Its length is how much? Its length is how much? Its length is dx only. Let theta and theta plus theta d theta are the angles between the components of tension and a horizontal axis at points P and Q respectively on the segment. Segment means it is a small piece. Okay, and here at a point P and at point Q. At point P, let it is angle theta, and at point Q it is at theta plus d theta angle. Somewhat angle is changes with respect to this one. So that is why here d theta is added. The transverse force acting on the small segment is equal to the difference between the perpendicular components of the tension at the 2 points. Here transverse force is a force acting on the small segment is. So transverse force means a force which is perpendicular to the string direction, stretching string direction. And see, it is acting on the small segment means small piece. How it is must be equal to the difference between the perpendicular components of tension at the end points. So at the end points the difference means at this point and this point the difference we have to take. So I am taking this perpendicular force as Fy. Perpendicular force means it is a force along y direction. So y component is added here to know in which direction it is acting. And now see, this is the t sin theta at x plus dx minus t sin theta at x means how we get here. See here from the diagram. So take this point P point and resolve it into two components like this. Okay, so tension is in this direction is let t. T is the tension, then it is making angle theta. So draw here like this, and draw one point from this point, or not like this, suppose see here. Okay, it is like this taken. Okay friends, so like this I resolved, and I'm making angle theta. So from this draw one normal on x-axis. Now see, it becomes a one right angle triangle. So like this, one right angle triangle, isn't it? One right angle. It is simply hypotenuse. Hypotenuse is what? Hypotenuse is tension T. Angle here how much? Theta. Okay. So then what is this component and this component? So if you want to know, let first to O, A, B, let me take these are the point and apply the cos theta. Cos theta is what we know, the adjacent by hypotenuse. Adjacent is OA. Hypotenuse is OB. Instead of OB, we can write T also. Why? Because from O to B is T. And here, bring T this side and write OA is equals to if you bring T this side, T cos theta. Okay, friends. So this component is what? T cos theta. Okay. So like this, we get this component as T sin theta. In the same manner we can get, that is T sin theta. So just you have understood like this, what we got this side T cos theta we got, and this side we can get T sin theta. Okay friends, so like this T cos theta and T sin theta we get, but no need to speak about the T cos theta. Why? Because total force is acting along y direction. So y component, what is that? That is a T sin theta we take. So T sin theta we get at the point T sin theta we get where? At the point at a distance x, and the same thing we get at a q also, that is at a distance x plus dx. Okay, it is at x distance, and again one more T sin theta we get, same process we apply, x at what? At x plus dx point. So difference between these 2 points is taken here as force. Okay, so this is difference. Okay friends, so like this so these two differences are taken in this manner. Okay, if you do not understand, please write comment. So okay, send post in comment, so then I will explain completely in the comment also. Or if you want to listen once again, I will explain without observing this diagram, or see by using this diagram once again. So it is like this. Okay, I resolve this point, which point? P point, and here making angle theta. Okay, already shown. So draw one normal from this point on x-axis. Now see, this is one right angle triangle. Okay, so this right angle triangle, let me take outside, right? Here making angle theta. So let point O A B. So this side is tension T. Where to where? From O to B tension is T. That means value is T. What we need? We need OA and AB we need. So if you want to get OA, then apply cos theta. Cos theta is what? Adjacent by hypotenuse. Cos theta is equals to adjacent is how much? OA by hypotenuse. Hypotenuse is OB, nothing but T. Bring T this side, then we can write OA is equals to what we write? T cos theta we write. So OA is equals to T cos theta we write. So OA value how much? So where from here to here? T cos theta we got. And if you apply the sin theta, then you can get AP value. So that is also I will show you once again. See, it is like this, and it is T. Already we got it is as a T cos theta we got. And this side I am making angle theta. Now apply the sin theta. Sin theta is equals to what? It is opposite by hypotenuse. So sin theta is equals to Opposite is how much? Opposite is OAB it is. So opposite AB. AB by hypotenuse is OB. OB is nothing but T here. T. So again bring this T this side. T sine theta is equals to AB. So like this we got vertical component as T sine theta, horizontal component as T cos theta. Okay. So we need here only vertical components only. Why? Because the force is a force acting along vertical direction only. That force is Fy. So we are taking difference between the this force and this force we have taken here as Fy. So see here. So this is the difference is taken outside. Okay, it is acting at x plus dx and it is at x only along vertical direction. Here T of sin theta is a component of tension at x, while T sin theta x plus d is a tensional force at point x plus dx. Yes. So now using Taylor series theorem, the value of f of x plus dx is written as. So it is a Taylor series formula. F of x plus dx is what? F of x plus f dash of x into dx plus f double dash of x into dx square by 2 plus so on like this. Now applying this thing here, then we get T sin theta plus dou by dou T sin theta by dou x into dx. Okay, so wherever f of x is there only T sin theta is substituted. That's it only. Wherever f of x is there only T sin theta. So here we have T sin theta. Here also we have T sin theta, but dash means dou by dou x. Okay, so like this, and higher terms not taken here. Why? Because okay, right, so like this we have to apply Taylor series in this manner. Now neglecting higher terms are removed, means we didn't take these are the higher terms, so we have to neglect only these two terms. We have to take this term and this term. Okay, two terms are taken. Substituting in the above equation 1. So what? So T sin theta x plus dx is we have to substitute where? In the equation C, in the equation 1, in the place of this, and here we have to remove x component. Alright, see here. So this is this totally substituted in the place of this as like this, minus T of T sin theta at x is removed, no need to take later. Okay, so like this side is substituted, and now these two gets cancelled. The remaining is this one only, that is this. Okay, so keep it light. It is a equation 2, and now when theta is very small, so generally the string is when it is like this, so this angle is making very smaller angle it has. So then sin theta is approximately tan theta. Why it is sin theta is approximately tan theta? When theta is small, sin theta is approximately equal to theta only. So for example, see here. So it is a formula. If you substitute in the place of theta as 0, okay, sin 0 is how much? Answer is 0. See, whatever answer you are whatever answer present here, the same answer we will get here. Sin of 0 is 0 only, so this is coming outside only. Okay, when it is happens, when angle is small, then only this angle may be the answer for this. Okay, like this for tan theta also. When theta is small, means when tan theta is 0, answer also 0. So that is why both answers we are getting same answer at the same angle. So that is why these two are equal, like this equal. Okay, and but we know tan theta can explain to us slope. Okay, slope means what? Y component by x component. Change in y component by change in x component is a slope. So that is why slope is written. Now we can replace this sin theta with this. Why? Because sin theta is equals to tan theta again is equals to dou y by dou x. So in the equation 2, where we have the sin theta, there we have to simply substitute dou y by dou x. Yes. Okay, here substitute. Now dou into dou square, dou x into dou x square. Okay. If mu is the linear density, then mass of the segment M is equal to length into linear density, that is mu dx. Why it is mu dx? See here, mu is a linear density is written as mass by length. Here length is how much we have taken, length is we have taken as dx only. Now bring this dx this side, mu dx is equals to what? M. So in the place of m, what we can substitute? We can substitute mu dx. So that is why it is a mu dx is given. According to Newton's second law, the force is given by F is equals to ma, and Fy is equals to, yes, along force is along y direction, so Fy. Mass, in the place of mass it is substituted. In the place of A, acceleration. Acceleration means what? Acceleration actually is, acceleration is what actually? A is equals to velocity by time. But velocity is what? Simply dx by dt we write. Okay. And so this velocity we can write dv by dt also. And if you substitute here in the place of v, what do you get? So you get this answer. Okay friends. Okay, A is equals to dv by dx dt, but v is equals to dx by dt. Now substitute this value here, then A is equals to, already d by dt is there. In the place of v, substitute this one, dx by dt. See, d into d, d square, dt into dt, dt square. Comparing equation, see the equation 3 and 4 we are going to compare. Why? Because both sides we have the Fy, then these two are also equal. So like this. Now dx, this dx gets cancelled, so this is the formula. And now what we are doing, bring mu that side, then t by mu. Okay, keep it as a equation 5 like this. The equation 5 is a second order differential equation. So for this general wave equation is given by dou square y by dou t square is equals to v square dou square y by dou x square. Now if you compare, this is same and this is same, but in the place of v square, t by mu is there. So that is why v square is equals to t by mu, v is equals to t by under root t by mu. This is the wave velocity equation. Okay. Now general solution of the wave equation. So general solution is just know what I have written above. Dou square y by dou t square is equals to v square dou square y by dou x square. Above equation is a second order differential equation whose solution depends mainly on what? X and a time. So here x and a time. The solution is a periodic function and hence expressed as a sine, cos or periodic function. So it's a solution we can express in terms of either sine, cos or periodic function. What are those things here? Therefore the solution is y is equals to sine omega t minus kx. So y is equals to sine omega t minus kx, or y is equals to sine omega t plus kx. So this is a displacement equation along positive x direction. It is also displacement equation along a negative direction. So it is along positive direction, it is along negative direction. So like that is why only we have taken negative and positive. Negative indicates positive direction, positive indicates negative direction, reverse. And in terms of cos also we can express like this, or in terms of exponential, see like this, y is equals to a into e power of I omega t minus kx, y is equals to a into e power of I omega t plus kx. Okay. Here what is the omega? Omega is the angular frequency and k is the propagation constant. Omega angular frequency is 2 pi f, or somebody will write 2 pi nu also, or 2 pi n also will write. And next k is the propagation constant, that is 2 pi by lambda, where lambda is the wavelength of wave. Okay friends, don't forget watching this video till the end.